Hello, I'm about to go through question 1I on Math 2019, and for this question we basically want to know how many pairs of positive real numbers x, y will satisfy both of these equations. Okay, so where do we even begin with this question? One thing we can do is to assume one of these conditions holds and then see where the other condition will be true. So because this first condition is simpler, I'm going to say, let's just assume that that one's true. Then, given that this holds, where will this equation be true? Now, the thing with this equation is we've got some linear terms and some exponential terms all mixed up together, and that's what makes it so complicated. So maybe it would be easier to have like terms with like. So how about I divide through by this y and also by this 2 to the x, and then we've got linear terms on one side and then the 2 to the power x terms on the other side. And it's okay for us to be dividing around like this because we know that y is a positive number, so it's not going to be 0. And also we know that this exponential term is never going to be 0 either. Okay, so now we want to know for what x and y does this equation hold when x and y satisfy this inequality. So what does this inequality tell us about the left-hand side of this equation? If x is less than y, then what do we know about x over y? We know that x over y must be less than 1. And if x is less than y, then what do we know about 2 to the y minus x? Well, we know that y minus x must be positive if y is bigger than x, so that's going to be greater than 0. And what do we know about 2 to the power of a positive number? So maybe we can look at the graph of 2 to the, well, I'll call it 2 to the z here, just so we don't get confused with our x's in our equation. But we can see that when z is positive, 2 to the z is greater than 1. So if y minus x is positive, then 2 to the y minus x must be greater than 1. So now what can you say about when this equality holds? Well, we've got the left-hand side is always less than 1, the right-hand side is always greater than 1, so this equality can never hold, right? They can never be equal to each other. So if this first condition is true, then the second condition is never true, so we can't have any pairs of x and y satisfying both of the conditions. Therefore, we want the answer A.